questo video andiamo a vedere le funzionalità base di SideScanSonar, appunto, questo software che permette appunto essenzialmente l'apertura e di maneggiare i file SideScan, quindi tutti i file con formato STF.
So I'll open up a session that Burns has created first, demo 1. So this is a bathymetry data set provided to us by NOAA for our training, and that's what we'll be using for this demo. So I'll start off by going to the Layers tab, and right at the top here, HIPS data. When I select that, I can go over to my Properties window. So now, rather than going to several different tabs to get this information, everything's within here. You can find all your general information, your coordinate system information. We have our new vertical reference that you can apply here. Again, this is just metadata and some other information about the project at hand. Also, if you click on your ship track lines, you can go over here to our drop down, and before, or in our previous versions, we added the SVP profile, or color by sound velocity profile, and now we have the color by tide. So when I enable that and middlemost click to refresh, you can now see in the lower corner here that one of the tide files has been applied for these few sections of the line and another tide file for the rest of the data. So this was when we applied SEDDF to the data set. Our separate tide files are applied to these separate areas, or these parts of the ship track lines. The final thing I'll be showing, I'm just going to turn this back to status again. I'll go into my subset editor and make a selection here. And let's load that. There we go. So if I rotate this, the vertical exaggeration looks good. I'll go up to here and our display filter. So if I enable this display filter and click on the drop down, I can now define what type of flagging for the soundings I'd like to show. So right now we can see this is the specific flag types that are on. So if I turn off these 3 flag types, and let's make a few selections of our data, and I'm going to flag some as outstanding, some as examined, designated, and I'll reject some as well. And we can see all these now, all those specific soundings are now gone from our view window here. So if I go back up here, let's say I quickly want to just pinpoint where these specific flagging types are. I can actually turn off my accepted data, and I can turn on each type of the flagging, so my rejected, designated, outstanding, examined, and now I can pinpoint these quickly and efficiently. With that being said, I can also have everything shown just by disabling or turning off the display filter, and now I can see everything now is displayed in the 3D in my subset view window. This is also can be used in your attitude, in your navigation, and in your swath editor. So these flaggings, even though some of the same flaggings aren't within there, you can view your rejected and accepted and turn them on and off using your display filter at the top here. So I'll pass this back over to Burns and we'll continue on.
Okay, thanks Dan. HIPS demo data set. So in this case we have the SideScan data set. I prepared a few things ahead of time, but essentially at this point, this is right after conversion in terms of this this data and its processed point or its processed state. So really, I haven't done nothing except convert it into the application. And of course, we're going to bring it in, select a line, and now I want to take a look at my data now that I have it converted. So the first thing I'm going to do is open up the SideScan window, and if I take a look in here. For those of you that have seen EdgeTech data before, you'll notice the quality is probably a lot higher than it was previously. As I mentioned about the scaling and imagery conversions. So now all the controls are inside my properties window as opposed to that tab where it used to be. So the nice thing about this is I can collapse each one of these items down when they're not in use, so it really makes it nice and compact. So of course, first thing I'm going to look at is my display, things like my playback speeds, my color map if I want to invert that, depending on what you're more comfortable with, all these things. So all that, again, is applied on the fly. The other thing, of course, we want to look at first, in this case, the SideScan towfish altitude came in from a sensor. Looks pretty good. I don't need to do any work there, but if I did, all my altitude settings are inside this dialog as well, so I can set my automated height detection tool configuration parameters. I can set all that in here. And off we go. So now when I want to see what that looks like, it used to be you'd run a slant range correction before you could see the final product. Now, as you may have noticed when I started it, all I have to do is click back and forth between raw and processed. So the process is really that simple now, and that's all I have to worry about inside the waterfall. So I've got a few corrections already turned off. I'm just going to flip back. So what you may have noticed that I just went through, here's all the corrections inside the SideScan editor, and everything is done on the fly now. So here's my TVG correction. I can do, let's say, linked, and let's say I want to try out different values. All I have to do is type these into the interface. I can see what effect that has in the data immediately, and that's all I have to do. Just that easy. So we have TVG, we have gain shift, so if you need to shift, say, a port or starboard, or both together, we have our gain enabled here as well. I'm going to come back to beam pattern in one moment, but I'll skip over. There's a despeckle, so that's essentially our aliasing algorithm we can apply. And a new correction for SIPS 8.1 is this gain normalization. So what we have here is dealing along track. Occasionally there's variation in the power and gain, maybe some motion from the platform, or what have you, cause these kind of banding striped artifacts inside the SideScan image. This gain normalization works along track using a moving average window to normalize, to sort of smooth out that ribbing effect or that choppy gain effect that you see going along track as the fish is moving through the water. So that's what that gain normalization does. And again, I can set that live in the display, see the effect it has in my data, all in real time. And of course, the last thing is beam pattern. In the past, what our users have done is made a selection inside the SideScan window like this, and then created a beam pattern from a small subsection of a line. Something we've been told recently, time and again, actually, is the more data you can feed into a beam pattern, the better it's going to be. So something new for this version, if I just hop out of SideScan Editor for a minute, you can actually select an entire survey and create a beam pattern from it. So in this case, I can create my beam pattern. I have one already generated here, but this would be the entirety of the process. That's all I have to do. And the nice thing about this is, if I come back the next day, I add a new survey line in. All I have to do is select an existing beam pattern file, and it's cumulative. So we'll simply add the new information to the beam pattern. I don't need to regenerate the whole thing from scratch. So, as I mentioned, I've actually got it already created for this particular data set. And in this case, it's already pointed to inside my waterfall display. All I have to do is turn it on. So I can do port and starboard separately if I like, and that's it. So literally in a matter of 5 minutes or so, I've set up my corrections on my image. I can take a quick run through the other survey lines if I'm interested, or now I can just jump straight into products. So in this case, the mosaic. Now I have a little bit to talk about there as well. So the next step, as I mentioned, is creating a mosaic from the SideScan image. In the past, our existing users will remember geobars, which are the individual line mosaics you create before stitching them together to make that final mosaic. It was a nice idea, but in practice, it was way more than most people needed. So in SIPS 8.1, you no longer need to make geobars. You just select the lines you want and go.
So what if I already created geobars? Can I still use these?
Yep, the original workflow is still supported. In fact, you still take that route if you need to customize different corrections per line. Or for instance, if you have a multi-sonar survey or surveys taken at different time periods under different conditions. We found that in most cases, our users have one sonar and a single survey they want to make a mosaic out of. And our new workflow is really tailored to that. When you create a mosaic without geobars, you use one set of corrections for the entire survey. Okay, so in terms of the mosaic, I've actually already created one here from my imagery, so I can turn that on. In terms of the process, all I have to do is select my lines, head to the process menu, and go to new mosaic. So again, I don't need geobars created. I can dive straight into this. And if I look under this advanced tab for the mosaic, I can see all the same settings from the SideScan editor or waterfall display. So there's my beam pattern, port and starboard, my gain normalization. So the two are linked. So whatever settings I configured in the waterfall when I go to create the mosaic, those are the settings it's going to use. So that, again, makes things nice and simple, really quick workflow for getting products out from SideScan image nice and quick. And that's the final result. So that's a 20 image.
Alright, so I'm going to first go back into SideScan Editor. I'm going to select this ship track line here, and I'll open SideScan Editor. So now that I'm in SideScan Editor, I'll show one of the new windows, going up to Windows and down to Attributes. So we have our Attribute window, which was added over here by our Properties window. And I'm going to start off by creating a contact. So I'll create a point contact. Now, if I go down here and expand my contact window, we can see the point contact that's going to be created is actually an underwater rock. And if I were to choose line, it would be cable. So this can be changed here, going by what you have for your options. So I'll go and I'm going to create an underwater rock. And then I'm going to go back up to my toolbar and select this particular contact. And we can see down here in the attribute window, we have some default attributes that are associated with underwater rock. So with that being said, I'm going to close out of here. I'll save that rock contact to the contact file. And I'm going to go over to my project tab and make sure my SIPS training project is selected. So with that selected, I can now go up to my file in catalog editor. And what that's going to do when it opens up my catalog editor is we can see SIPS training is the title up at the top here, and this is actually the attributes and objects that are within every HIPS file defaults. And now any new attributes or objects that I create will be automatically saved to this SIPS training project into my HIPS file. So let's start off by adding some actual new customized attributes. So I'll expand my attributes. You can see all of our default attributes that come with every HIPS file. I'll select attributes, right click and go to add, and we have several types to choose from. And we'll start off with the enumeration. So I'll go enum and go OK. And we'll give this a name at the top. We're going to call this type. And for our name, let's give it a name of feature type. And description type of feature. So now that we've filled in this information, we have a new acronym type. Let's give it some options to choose from. So I'll expand this down, and for my first name, I'm going to say rock, enter. We'll add a second option, wreck, and let's add one more and call this one kelp. So now for our new attribute, our type attribute, we have 3 options to choose from. And that type attribute, as you can see, has been added here. So let's generate one more. I can go up to my toolbars, add, and let's do a date and go OK. So under date, I'm going to call this one reported on. And again, I'll give it a name and a description. Reported on. So reported on and date the feature was reported on. So with that, I can go save. These 2 customized attributes have now been saved to my HIPS file. and I'll just collapse my attributes and expand my objects. So we can see there's several objects here that come by default. There's also the option of going up to the toolbars or right-clicking on our objects and adding a new object. So we're going to be working with the underwater rock, but we can also add customized attributes to critical soundings or our lines. So I'm going to extend my underwater rock, and again, these are the attributes that come with that. But I can right-click on that and go to Add. And with Add, I can now add my type and my reported on customized attributes to that particular object. And with that, I can also set some of these as mandatory. So if I wanted to make sure that type was always filled in, I could set that to true, and again now save, and I can exit out of my catalog editor if I'm all done, and all this information is now saved within my .hips file for this SIPS training project. So I'll exit out, and I'm just going to quickly close this project down and reopen it. And I'm going to select this bottom line. This is where I created that rock contact. And I'll go back into my SideScan editor. And as we can see, if I go up here to my selection and select it, we now have the type highlighted by red. So it's a mandatory, which I can define as rock. And I can also put in a Julian day. And go OK. So now if I wanted to add one more contact, let's just add one here quickly. We can see that information could be filled in for here, and I could go back to the previous created, and that information has been saved once I save, or if I were to exit, it would prompt me to save that. So with that being said, I'll pass this back over to Burns, and we'll continue on with the slide.